You might have run into a black hole and not even know it. No, not a real one, like those that are in outer space, but an internet black hole. It can happen when the website you're trying to access doesn't load, or your email seems to get lost forever in cyberspace, never reaching its destination. A research team at a famous university in the US started looking at this phenomenon, and what they found was amazing. For starters, the situation of things getting lost on the internet happens way more often than you think. To help with identifying these internet weak points, researchers have put together an online interactive map, which updates every 15 minutes. On this map, online black holes are pointed out with red flags. If your message fails to get through to your friend while you're emailing each other, it may be because your wireless network has some sort of error, or even because a specific server is momentarily going down. Those are the simple, explicable cases. Others are more mysterious and harder to piece together. At this precise moment, a lot of messages all over the planet are lost to online black holes. Think about it this way. All information sent across the internet moves around like packages, being transported from one area to another, even to the remotest corners of the world. Most people have experienced getting something they've ordered lost in the mail, a letter or a package. It may get destroyed, or it may even fall off from the delivery vehicle when it was loaded during transportation. Either the transportation company or the seller usually takes the loss, simply refunding you the money you've spent or resending the product. It's the same with information online, only in this case, we have no idea where it goes once it gets lost. Here's how the interactive map works. Researchers send test messages across the globe to look for computers that can be reached. Short communication failures are ignored. These sort of problems become black holes when they fail to respond within 15 minutes. Overall, the research uncovered that more than 7% of computers all over the world experienced this type of error at least once in 3 weeks. Did this map help manage to figure out what internet black holes are? Not really, but it is a first step in uncovering the mystery. So far, it's been most useful for professional network operators who really need to keep the internet running smoothly. Another one of those internet sensations was that of the story of the most mysterious song on the internet. And it goes back to 2007, when a person posted a clip of a song on a Canadian radio station fan site. The same comment stated that the song was recorded from a German radio station some time back, but had no idea who the singer was, or how old the song may have been. The tune itself didn't help much either. It had a simple beat, monotone vocals, and sounded very similar to most 80s hits. It sounded familiar, but at the same time, it was really hard to pinpoint where it might have come from. The information about this song spread like wildfire on the internet, but at one point, no one knew who wrote it, who sang it, or even when it might have come out. It wasn't long until most music aficionados on the internet started calling this the most mysterious song on the internet. The person that initially posted the comment joined the search eventually, saying that it was her brother that recorded the song from a radio station years prior. He thought the song was nice and hoped it would be replayed eventually so that he could find out the name of the artist. That never happened. Over the years, countless people have tried to claim ownership of the song, but they've all been proven as fake. Some have even thought that the original post, looking to find out who the singer was, had no other purpose than to draw attention and create a frenzy online. To this day, no one has yet to figure out the author of that song, but communities online have helped a lot of people ever since this first case identify their favorite lost tunes. Other internet mysteries are way creepier. In June of 2011, a young man named Frank passed away suddenly from a heart condition. 5 months later, his best friend Tim started receiving emails from him with a weird subject line. It simply said, "I'm watching." Apart from the intriguing intro, the email also contained information that only the two men could have known. Sometime before, they were both in Tim's attic, having a conversation about what to do with that space. As far as Tim knew, no one else heard that conversation. Weirdly enough, the email urged Tim to start cleaning up his attic so he could finally use it. His best friend wasn't the only one that received emails from the beyond. Frank's cousin also received a message from him, talking about a broken ankle. Surprisingly, his cousin really had injured his leg a week prior to receiving the email. To this day, no one knows who sent those emails. As far as his friends and family know, nobody had access to Frank's computer or passwords. Most of them didn't believe his account might have been hacked either. If you're a fan of internet unsolved cases, you've surely heard of the name John Titor. It all started back in 2000, when a user under this name started posting information on the internet one day, claiming he was a time traveler. He claimed to be from the future, and went on to make some predictions about the future. For starters, John Titor said that he was a soldier that came all the way from the year 2036. In this specific year, apparently a computer virus had already destroyed the world. The reason why he came back was to retrieve a 1975 IBM computer, which was crucial for saving the world from the virus. Technically, he didn't need to travel to the 2000s, but he made a short detour because he wanted to visit his 3-year-old self. Over the course of a couple of months, this user answered every question people threw at him, describing the future in a very cryptic manner. He always made sure to add a disclaimer to the information he provided, stating that alternate realities do exist, so his rendition of the future might not be the one bound to happen. The most obvious question people asked was, how did Titor manage to time travel? Throughout his many replies online, he gave people a series of technical specifications on how time travel ends up working in the future. He also provided complex algorithms and even pictures of the machine. The photos were really bad quality though. Will cameras get really bad in the future? Hard to believe. At some point during his online existence, John Titor simply stopped posting. His followers were quick to assume that he might have finished his mission, and that he had to travel back to the future to save humanity. After he disappeared from online forums, a lot of people claimed to know what was behind the story. A journalist was even contacted by 2 different people claiming to be John himself. Both were a tad bit offended they weren't contacted in the first place for an interview. The weirdest of them all is probably the story of a woman claiming she had been John Titor's girlfriend when he traveled back to 1975. Their relationship even produced a boy, which, if you think about it, was technically born before his father. Most of the things John Titor predicted did not happen. So why did his story become so popular? Out of sheer luck, some would say. The internet is filled with all sorts of weird stories, mysteries, and hoaxes. Some of them get enough attention that they get rapidly spread throughout the internet, even if there is no proof. And some people believe they are.
Ever wondered what it would be like to hear the sound of a black hole? NASA's got you covered. Here is a screaming black hole. Screaming in space? I thought in space no one can hear you scream. Well, let me explain. Using a telescope, NASA examined the movements of hot gas in a cluster of galaxies in 2002. Then they converted what they found into a sonification. The sound, how can I put it politely, wasn't appealing, but that's okay. After all, you're able to hear the noise hot gas produces in a cluster of galaxies 250 million light-years away. Hey, how would you like to hear the sound gas produces right here on Earth? Never mind. Sound waves already existed over there in the gas cluster, so experts just rescaled them to the range of human hearing. This is how they converted the input coming from the telescope. The principle is universal. In our atmosphere, we can hear stuff because pressure waves move through a medium like liquid or gas. Sound waves in these galaxies can also move because they're surrounded by gas. What does it have to do with black holes? Well, the thing triggering those pressure waves in the cluster is a giant black hole. To be more precise, it's a supermassive black hole that weighs millions of times more than the Sun. Wow. Experts still don't fully understand the relationship between supermassive black holes and the clusters surrounding them. They only know that these two evolve together. They're interrelated. The cluster feeds the black hole with new material and so on, and in return, the black hole heats the cluster. That's all we know. Now, this made me wonder how large the biggest black holes are. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. Naturally, the biggest ones fall into the category of supermassive. The largest black hole in the universe we've discovered so far is about 66 billion times larger than the Sun. It's one of the brightest objects in the universe. Astronomers keep scanning space and finding new black holes. But have you wondered when the first black hole was spotted? It was discovered by different researchers independently in 1971. Scientists first confirmed that these objects were formed from the remnants of massive stars. After a black hole appeared, it then consumed all the nearby objects. Here is a quick recap of how these space objects work. Their gravitational force is super strong. Nothing can escape a black hole after crossing the event horizon. Black holes eat everything, just like me. I mean, even light gets trapped inside them. What's even cooler/scarier is that the laws of time and space become distorted there. If you were falling into a black hole, you would realize that time slows down there. Einstein explains this in his famous general relativity theory. In very, very basic terms, time gets affected by how fast you are moving at extreme speeds. NASA has discovered a rapidly growing black hole, but don't worry, the world isn't in danger. This black hole has been in front of the eyes of astronomers this whole time. It's in a region of a well-studied sky field. Astronomers say that this hole formed 750 million years after the Big Bang, the birth of our universe. So why are black holes so bright? Well, that's a bit ironic. When I defined this space phenomenon, I said that black holes were so dense that even light got trapped there. But ask any astrophysicist, and they'll confirm that black holes are among the brightest objects in space. That's because black holes don't exist alone. They sit at the centers of galaxies and are usually surrounded by clouds of hot gas. And these clouds create cosmic auroras around black holes. I must mention, though, that you can't see a black hole directly. What you see is actually the effects it has on its environment. For instance, you can see space objects being ripped apart by a black hole. Remember when the first time ever silhouette image of a black hole was shared with the public in 2019? Proof, you fellas. You wouldn't really see the black hole if there was no orange ring. Why is the ring orange and not green or purple? The dark shadow inside is the shadow of the black hole. The glowing orange of the bright ring in the image isn't the real hue of the gas. I'm a little heartbroken here. It's a representation picked by researchers to depict the brightness of the emissions. A scientist explained that yellow is the most intense emission, red is less intense, and black has little or no emission at all. In the optical range, this ring would likely seem white, perhaps tinged with blue or red. Now, spaghettification is a real word. That's an astonishing ability black holes have. If a giraffe fell into a black hole, it would stretch into a long spaghetti-like strand. On Earth, a giraffe's legs are closer to the center of Earth, so they're more powerfully attracted to the surface than the animal's head. This rule works in the animal's favor on Earth, but would work against it inside a black hole. In a black hole, there's extreme gravity. The closer the giraffe's legs got to the center of the black hole, the more the pull of gravity would stretch them. And the closer to the center the giraffe got, the faster its legs would move. But the top half of the giraffe's body would be farther away, so it wouldn't move toward the center as fast as the legs. Here comes the spaghettification. Can we have meatballs with that? No? Okay. The only difference between a black hole and our sun is that the center of the hole is made of super dense material. It provides the black hole with a strong gravitational field that can trap everything, including light. This is why we can't see black holes. Did you know that, theoretically, you could turn anything into a black hole? For instance, if you shrank the sun to approximately 4 miles across, you would compress the matter inside to an extremely small size. This would make it so dense that our star would turn into a black hole. You could do the same with a planet or even your own body. Is there something called a white hole, or is it just a myth? White holes exist in theory. Hypothetically, they function in the opposite way to black holes. Nothing can enter them. Physicists think of black and white holes as yin and yang, or two sides of the same coin. For them, a white hole looks exactly like a black hole, which makes different things come out of it. But the existence of white holes hasn't been proven yet. And how about wormholes? There are so many movies about black holes and wormholes. How many of them are based on reality, and how much is fiction? Some people believe that black holes function like wormholes. You go inside and exit in another part of the universe. Since we still have a lot to learn and discover about physics, no one can prove this theory is wrong or right. Astrophysics says we need to have a solid theory that unifies general relativity with quantum mechanics. Black holes are among the largest structures in the universe, but there might be tiny specimens. The mass of the smallest black hole we know about is only 3 times greater than that of our Sun. Now, apparently, black holes can vanish. Stephen Hawking developed a theory of Hawking radiation. According to it, radiation decreases the mass and rotational energy of black holes, and ultimately they evaporate. This process occurs very slowly, though, if we're not talking about small black holes. Astronomers have discovered an elusive black hole in the neighboring galaxy. What makes this one special is the fact that it's the first dormant stellar black hole outside of our galaxy. This type of black hole is hard to observe because such holes don't interact much with their environment. They don't emit as much radiation as other black holes. Well, back on Earth, what about sinkholes? Well, different physics. Yet, if you cross the event horizon, your whole car can disappear. Whoops! Dark, ever-hungry monsters live all across the universe. They're born when massive stars blast into space. Black holes, as heavy as Earth, are just as large as a ping-pong ball. They don't have a surface, but their gravity is so strong even light can't escape it. Black holes don't have physical boundaries like a membrane either. The event horizon, which is closest to a typical boundary, is a threshold which, after passing, you can't get out. For a star, running into a black hole normally ends in a spectacular light show and its destruction. Just one star that astronomers know of managed to survive an encounter with a black hole as heavy as 400,000 suns. It happened in a galaxy about 250 million light-years away from Earth. Astronomers with really powerful equipment noticed bursts of X-rays that raged in space every 9 hours. They thought they must be Mayday signals from a star trapped by a cosmic abyss. The star was an average red giant when it met its new friend for the first time. When they got too close to each other, the hungry space monster couldn't resist the temptation and snacked on its guest. When it was done with the star's outer hydrogen layers, all that was left was the star's core. Eventually, the poor thing turned into a white dwarf. But for some reason, the giant space monster couldn't finish the meal and trapped it in its orbit for later instead. Ever since, the now white dwarf has been traveling in 9-hour laps. It stays far enough from the hole so it won't fall in or get swallowed. Its journey isn't going super smoothly. Because of gravity, the orbital path is constantly rotating. After 2 days, it resembles a spirograph pattern. As the black hole keeps snacking on it, the star keeps losing its mass and growing in size. Its own orbit is becoming more and more circular. Scientists believe one day it will be able to spiral away from its mean friend and turn into a planet the size of Jupiter in 1 trillion years. That's 70 times longer than the universe has existed so far, so it might not ever happen. The Milky Way alone has hundreds of millions of black holes, and there are way more beyond it. They might feed on other stars and release them in other galaxies. The telescopes that exist now might not be strong enough to spot them. Most galaxies, including our Milky Way, have supermassive black holes at the center. They can be billions of times heavier than the Sun. Others of their kind are only 3 times the mass of the Sun. The nearest black hole to the Earth was spotted 1,000 light-years away, just around the corner in galactic terms. It's in a star system you can see with an unaided eye. Scientists found it when they noticed a star behaving weirdly. It was a giant, rotating like crazy. They guessed it must have a powerful gravitational companion. The hungriest black hole astronomers have spotted so far weighs as much as 34 billion suns and is about 6 times bigger than the one at the center of the Milky Way. It eats the equivalent of 1 sun every day. Sometimes black holes even devour others of their kind that happen to be too close to them. Before you get on a spaceship to escape to some safe, no-black hole galaxy, here's some good news. Even though they're supermassive, they don't have a radius large enough to destroy Earth. And even the hungriest of them are safe to watch from a distance. No black hole should come closer to our planet than the Sun for as long as the universe has existed, multiplied by 10 billion times. In the unlikely case one of these scary things passes by Neptune, it could affect the Earth's orbit. That would be no good. In theory, anything can turn into a black hole. The only difference between it and the Sun is the material their centers are made of. It's incredibly dense in those huge space monsters. In reality, there's just one known way to make a black hole. It has to be the gravitational collapse of a supermassive star, 20 to 30 times the mass of the Sun. So, the Sun will never ever become a black hole. If it happened, though, and the former star retained its mass, it would still have the same gravitational power. Earth would still keep going around it and wouldn't get pulled in. Its orbit would also remain as it is. The only huge problem would be the lack of sunlight. In reality, the Sun isn't massive enough for such a transformation and will eventually become a white dwarf. A black hole won't ever eat an entire galaxy for lunch. There are about 400 billion stars inside the Milky Way. Just around 0.1% of all the stars that will ever form will end up becoming black holes. The ever-hungry supermassive monster, located right in the middle of a galaxy, has an impressive gravitational reach. But even that wouldn't be enough. It has already eaten most of the stars that were close to it. It already weighs like a few million suns, so it can't grow much larger even if it keeps snacking on sun-like stars. Galaxies will keep bumping into each other, and black holes will keep growing and merging. But because the universe is already huge and keeps expanding, these collisions and mergers won't go on forever. Black holes will travel this huge space like rogue stars. They won't even be able to eat the dark matter on the outskirts of galaxies. Eventually, all the black holes will perish, but that would be a long, long time from now. If you ever become a space explorer and travel far enough to meet a black hole and fall into one, your life won't instantly end. Instead, things will be way more complicated. The way you perceive space and time will change, and your reality will split in two. In one of them, you'd cease existing. In the other, you'd live and enter the hole unharmed. When you go deeper inside the hole, you'll notice space becoming curvier and curvier. At the center of the hole, it's infinitely curved. It's called singularity. Laws of physics based on the ideas of space and time don't have power here. In a large enough hole, millions of times more massive than the Sun, things would go perfectly smoothly for you. And you just keep free-falling, feeling no gravity. You could just keep falling and falling in total emptiness until you reach singularity. You'd have no chance to move in the opposite direction. In there, space and time switch roles. Time is constantly pulling you forward on Earth, but figuratively, and it would be doing that quite physically inside the hole. In a smaller hole, the force of gravity would be stronger at your feet than your head. That's why you would go through spaghettification. This is how scientists call the process when you compress horizontally and stretch vertically like spaghetti because of crazy gravity of the black hole. Speaking of spaghetti, how are black holes like an Italian dinner? Because once you go pasta the event horizon, you get spaghettified, and since you're all by yourself, you'd be feeling cannelloni right now. Wow, now I'm hungry. Meanwhile, if you had a fellow space traveler who, for some reason, didn't end up in the black hole, it would look all different to them. They'd see you stretch and grow, like through a huge magnifying glass. The closer you get to the edge of the hole, the more it would seem like you're moving in slow motion. Then you'd freeze, and the flames would surround you. You'd be in two places at the same time, living different destinies, but there would still be just one copy of you. This is how black holes teach us nothing is real. Reality can be different to different people. Some scientists believe that we're all living inside a huge black hole. Everything in the universe started with the Big Bang. But there's a theory saying there was also something before that. It was a super dense seed that had all the mass and energy of the universe concentrated in it, about as heavy as 1 billion suns. It was 1 trillion times smaller than any particle humans can observe. This seed could be born inside a black hole. If you believe there's more than one universe, black holes could also serve as doors between those universes. It could be like a root that two trees share. You can't see a black hole directly because it doesn't give off any light. Scientists used to be able to only spot them by what they were doing to their surroundings. When over 200 scientists around the world worked together, they managed to take the first pictures of that space oddity. The equipment they used, added together, would be the power of a telescope the size of Earth.
Emergency lights are going off, sirens blaring. The spaceship is shaking like crazy. The cosmic darkness beyond the portholes is illuminated by pulsating flashes. The astronauts are strapping themselves in and looking at the screens, cold sweat breaking on their foreheads. Straight ahead, space is cut in half by a blinding beam. Nothing in the universe can stop it. It looks like a humongous airplane jet stream, millions of times more powerful than any jet could make. There's no way to go around it. The leader of the space expedition orders everyone to turn around immediately. That was a black hole jet, a real monster of space. The holes, like huge vacuum cleaners, swallow everything that falls beyond their event horizon, the boundary between space-time and the place where it disappears. If you find yourself close to this border, you're doomed. Even light can't escape the gravity of a black hole, and it's the fastest thing in the universe. The holes not only absorb matter, but also shoot jets into space, mysterious beams thousands of light years long. There are no black monsters near the Earth, but let's imagine if one suddenly popped up close to the sun. The hole immediately starts devouring the star. Strong gravity pulls one side of the sun more than the other. The hole tears the sun into ribbons, eating it just as you would eat spaghetti off your plate. Physicists call this phenomenon spaghettification. When the monster's finished its meal, it hiccups, and, like laser swords, two jets cut our galaxy in half. Astronomers are observing a similar catastrophe right now, billions of light years away from us. A black hole from the 3C321 system is bombarding a nearby galaxy with a jet of X-rays, gamma rays, and electrons accelerated to the speed of light. The onslaught has been going on for 1 million years, and we're lucky it's taking place at a safe distance. If a jet comes close to a planet similar to Earth, it'll vaporize the atmosphere and the ozone layer. All life on the surface will disappear. Only deep underground dwellers will survive. If a black hole does appear next to the sun, though, we won't live long enough to see the jet. The monster will absorb the energy of the star, and we'll simply lose all heat and light. The Earth will cool down, delving into eternal darkness. But, like anything else, jets can do good things too. Like fertilizers helping crops to grow, The energy of the rays squeeze the space clouds, and new stars will be born from them. Imagine a drain in the bathroom through which water flows into a pipe. The water moves in a spiral, and some of it rotates around the hole. Now imagine that the black hole is the same drain, and instead of water, there's the stuff called plasma. It spins rapidly, gets magnetized, and collects into a huge accretion disk. Plasma starts to glow, and at some point shoots two streams into space. The black hole V404 Cygni lies 8,000 light-years away. It's like a firework display that weighs as much as 10 suns. The problem is, they forgot to install it securely, and the wick was prematurely set on fire. The hole is powered by gas from a nearby star. It provides infinite charges for the space fireworks. The V404 Cygni jets don't just fire from the poles, but in every direction. A disk as wide as 7 suns is spinning around the black hole. The inside of the disk is wobbling like a top that's about to stop spinning and fall. Scientists believe the wobbles and random shots are caused by distortions of the space-time continuum. Black holes are not the only ones who know how to put on a space show. Their main competitors are gamma-ray bursts. Science doesn't know exactly how they appear. Most likely, it's because of the decay of a huge star or the collision of neutron stars. Satellites record one gamma-ray burst every day, but at least 500 outbreaks occur in the universe within the same time period. An amateur astronomer first seeing the observable universe may feel like a movie star on the red carpet. Only they'll be blinded not by the lights from the cameras of journalists and fans, but by constant gamma-ray bursts. If there is a flash near the Earth, our planet will feel like a candle in a snowstorm. Imagine that you live in the future and can take off on safe interstellar flights. On your spaceship, you fly to a planet that looks like Earth to see a gamma-ray burst with your own eyes. Your ship is cutting into outer space and landing on the planet in question. As soon as you step on its soil, though, you feel it. Every living thing in this world is waiting for something terrible to happen. Frightened birds are flying through the sky. Animals start running out of the forests and looking for shelter. The wind makes the leaves rustle, and it's like they're whispering to you, "Save yourself, get out of here." Then, the wind grows stronger and turns into a storm. A bright flash appears on the horizon. After a few seconds, the light intensifies. Someone huge has turned on space floodlights. Everything is lost. There is only light. As much energy is released in 1 second as our sun generates in 10 billion years. 10 seconds pass and the show is over. The planet is moving through space, and the flash has only hit a part of its southern hemisphere. But that's enough for things to go badly. The gamma-ray burst was a pretty short one, so it probably wouldn't have vaporized the oceans or blown away the atmosphere. But the ozone layer, which protects the planet from the rays of the nearest star and cosmic radiation, still disappears. All life in this world abruptly ends. The picture is terrible, but there's no need for us to panic just yet. Scientists believe the probability of a similar catastrophe on our planet is 0. But the Earth hasn't always been so lucky. The Ordovician extinction occurred 450 million years ago. Perhaps a gamma-ray burst was to blame. Its epicenter was 6,000 light-years away from Earth. Harmful UV light hit the planet's surface, reducing the ozone layer by 40%. More than half the plants and animals disappeared. But life continued to develop, and after 200 million years, dinosaurs began roaming the planet. Eta Carinae is a hypergiant double star. It's almost 200 times heavier than the Sun, and in 10 seconds, it emits as much light as the Sun in a year. It's as far as 7,500 light-years away from Earth. But in 1843, dwellers of our planet saw it in the night sky without telescopes. This was possible thanks to an explosion. These beautiful clouds of gas and dust are the consequences of those events. We can say these are huge ruins of a star, but they look cool. Over the next 1 million years, Eta Carinae will continue exploding and form a gamma-ray burst. But even here, humanity needn't worry. The direction of the gas clouds indicates that the future burst beams won't hit the Earth. Our planet is under siege. Right now, 30 million space objects, varying in size from a grain of sand to a car, are flying towards the Earth. But our atmosphere burns all border violators. Scientists are constantly monitoring space, and they haven't found a single space rock potentially hazardous for humanity. But this doesn't mean it doesn't exist. A huge asteroid arrives to Earth once every 2 million years on average. Here are the surfaces of the Moon, Mars, and Mercury. Craters cover them like cheese holes. These are the tracks of asteroids that have been bombarding their surface for millions of years. An atmosphere is an excellent barrier against the rock shower from the skies. But every year, around 500 large objects still make their way through it. Most of them fall into the ocean or sparsely populated areas and remain unknown. Geological activity continues on the planet. The continents move, mountains rise and fall. As you watch this video, the landscape of the Earth is changing. All of this erases all traces of meteorites that have fallen on the planet.
Imagine a giant star, a space object with ginormous mass, collapsing down into gravitational singularity. This is a region of space where the density of matter becomes infinite. In such areas, the standard concepts of space and time don't have any meaning anymore. No wonder such objects have captured our imagination. These days, we even have a few photos of black holes, or rather, the space around them. The first photo of a black hole's event horizon was taken in 2019. The event horizon is a point of no return on the outskirts of a black hole. When something, for example matter, radiation, or light, reaches this boundary, there is no way for it to escape. We can use the event horizon to estimate the size of the black hole. The larger it is, the more massive the black hole you've come across is. An international team of scientists that consisted of more than 200 astronomers had been working for years to get this result, and eventually their efforts paid off. The black hole, the region around which they managed to capture, is about 55 light-years away from Earth, at the center of the galaxy M87. People saw this amazing image thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it was tricky. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. But even though now we kind of know what a black hole looks like from the outside, we haven't figured out what might be waiting for us on the other side. Many people imagine black holes as bizarre portals to other worlds, dimensions, or parallel universes. We'll get back to these theories a bit later. So, why not jump into a black hole and go all the way to the other side? Unfortunately, such an escapade is bound to end tragically. If something gets close to a black hole, there's no escape. You might argue that you don't need to go back. After all, you want to explore what's ahead. True, but there's another problem. The force of gravity around a black hole increases dramatically the closer you come. It even creates the effect of spaghettification, when an object gets stretched into thin strands of space pasta due to the effects of gravity. When spaghettified, the matter then gets pulled into the black hole's orbit and flattened into a swirling and glowing disk of material. And eventually, this matter settles into a nice orbit around the black hole, quite far away from the point of no return. And that's not how you want your space adventure to end. Well, I don't. Getting something to cross the event horizon isn't as easy as it may seem. The material needs to be pushed out of its stable orbit around the black hole. In other words, something must make it fall in, just like it happens with the Sun and Earth. Despite the star's enormous gravity, our planet doesn't get pulled towards it, right? One of the few reasons why the material might cross the event horizon is collisions between particles. By crashing into one another, they gain some energy, and that's enough to send them spiraling into a black hole. An object entering a black hole is instantly transformed. From the outside, it would seem as if the object starts moving more slowly, because time distorts near the event horizon of a black hole. From the perspective of the object falling into this space monster, it would take an infinite amount of time for it to become a part of the black hole. When it happens, its mass will be added to that of the black hole. But even if you somehow manage to survive entering a black hole, you wouldn't be able to come out on the other side. Now, I might disappoint you right now, but black holes don't go anywhere. There aren't any holes involved. And these space phenomena aren't even black, or at least that sort of black. Black holes might seem inky because even light can't escape their clutches, but this has nothing to do with their color. Anyway, when you cross a black hole's event horizon, all paths lead to the singularity, even if we talk about a photon of light moving directly away from it. But the main problem here is that singularities are mathematically impossible. That's why some scientists suggest that when all this weird stuff happens inside the black hole, its mass gets linked to the expansion of the entire universe. And such a black hole is like a rubber band, stretching along with the universe as it expands. And as it stretches, its energy increases. And since mass and energy are proportional, the mass of the black hole increases too. But this new mass creates a pressure that makes the universe expand even more. That's the reason the universe is expanding faster and faster all the time. Wow, that sounds insane. Then, there's also a theory about parallel universes, and this multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities. According to this theory, we live in a bubble that is just one of many other bubbles. And these bubbles constantly pop up and vanish. And guess what? Right, black holes might be tunnels between these universes. Or rather, not tunnels, but wormholes. This idea that black holes could be wormholes leading to other galaxies or universes has been around for some time. It gained some fresh ground in the 1980s when a discussion started about whether an object could physically travel through such a tunnel. But since there's no firm evidence that a black hole can allow for such a passage, this remains just an idea. But if black holes lead to other galaxies or other universes, there must be something opposite to them on the other side. That's where the concept of white holes comes into play. So far, white holes are only a theory. You can imagine them as black holes in reverse, or as a ball that falls to the ground and then bounces up again. In other words, everything that falls in bounces and comes out through the white hole. But how might white holes form? One of the theories speculates that a white hole might be a black hole that has almost collapsed in on itself and then exploded outward again. What if, inside a black hole, there's a long tube that keeps getting longer and narrower until it reaches the point in which it gets so narrow that quantum effects make it bounce back? And then the super long and super narrow tube is getting thicker and wider again, and we've got a white hole on our hands. But then, what could make a black hole want to turn itself inside out? According to quantum mechanics, many things we perceive as continuous are granular. Even light is not a continuous wave, it's made up of photons. So if we apply quantum mechanics to space itself, we'll find out that the cosmos is granular too. It means a black hole can't squeeze stuff down to infinity. At some point, it will reach its minimum size. And this matter, or whatever is falling down the black hole, will have to stop and bounce back, giving birth to a white hole. What matter would such a white hole spit out? Some experts think it could be ordinary electromagnetic radiation. It would be unrecognizable from what originally fell into the black hole, since things get horrendously squashed after entering black holes. And while black holes have an event horizon, white holes would have a reversed event horizon. It would prevent anything from entering a white hole. And because of this feature of white holes, if you decided to travel to one, you wouldn't be able to even get close to it.